Have you ever looked at a room or a piece of paper and wondered how much space is actually in there? Well, that's exactly what we're jumping into today, the basics of calculating area. We're going to demystify the simple formulas for the most common shapes you see every single day. Let's do this.
So, here's our game plan. We're going to start with what area even means. Then we'll grab one simple formula and see how it helps us understand rectangles, squares, triangles, and finally the trapezoid. It's all going to build on itself one shape at a time.
All right, first up, measuring 2D space. Before we get into any math, we got to be on the same page about what it is we're actually measuring. Nailing this down is the key to everything else.
So, what is area? Simple. It's just the amount of flat space inside any 2D shape. Now, to figure it out, we need two measurements. The base, you can think of that as the bottom, and the height. And here is the absolute golden rule. You have to remember this. The height is always perpendicular to the base. That means it makes a perfect 90-degree angle, like the corner of a book.
Okay, it's time to meet the hero of our story. Area equals base times height, or as you'll see it, A equals BH. This little formula is the powerhouse behind calculating the area for so many shapes we run into.
Let's kick things off with a shape we all know and love, the rectangle. The formula works perfectly here. You just multiply the length of its base by its height. That's it. Nice and easy.
Okay, ready for a little pop quiz? Let's say a rectangle has a base of 1 meter and a height of 40 centimeters. What's its area? Now, this seems straightforward, but there's a little trap in there. See if you can spot it.
And there it is, the trap. Before you multiply anything, and I mean anything, your units have got to be the same. This is, without a doubt, the number one rule. It'll save you from so many common mistakes. You just can't mix meters and centimeters.
So here's how we solve it step by step. First, we've got to make those units match. Let's turn 40 centimeters into 0.4 meters. Now we're talking. We can plug those numbers into our formula. 1 meter times 0.4 meters gives us a final area of 0.4 square meters. See how crucial that first step was? Now what about this guy, the parallelogram? The easiest way to think about it is just as a slanted rectangle. And because our formula only cares about that perpendicular height, not the slanted side, the formula is exactly the same, base times height. Okay, let's lock this in. Quick question. You've got a parallelogram with a base of 8 feet and a height of 12 feet. What's the area? Yep, we just used that same formula. 8 feet multiplied by 12 feet, and that gives us 96 square feet. It's really that simple. So we know how to handle rectangles, but what happens when that rectangle's base and height are exactly the same? Well, then we get a very special case, the square. With a square, we don't even need to talk about base and height. Since every side is identical, we just call the length S for side. That means the area is side times side, or to put it more elegantly, side squared. Let's test that out. If you have a square and one of its sides is 25 inches long, what's its area? We just follow the formula. We take A equals S squared, we swap in 25 for S, and 25 times 25 gives us 625 square inches. Done! Okay, now for a clever trick. Imagine you have a parallelogram, and you take a knife and slice it perfectly from one corner to the opposite corner. What are you left with? 2 identical triangles. And that simple idea, that's the whole secret to their area formula. And that's exactly why the formula for a triangle's area is 1/2 base times height. It's literally half of the parallelogram that it came from. Once you see that connection, the formula is almost impossible to forget. So let's try it. You got a triangle with a base of 10 centimeters and a height of 6 centimeters. What's its area going to be? Well, first we do what we know, multiply the base and height. So 10 times 6 gets us 60. But since it's a triangle, we just have to take half of that. So the final area is 30 square centimeters. And here we are at our final section, the 2-base challenge of the trapezoid. This is the last shape we're going to add to my geometry toolkit for today. Now, I know what you're thinking. This formula looks a little more complicated, but the idea behind it is actually pretty cool. A trapezoid has 2 parallel bases, which we're calling B and C here. All the formula is really telling us to do is find the average of those 2 bases first and then multiply by the height. Okay, final boss battle. We have a trapezoid, the height is 9 feet, and the 2 bases are 14 feet and 8 feet. So how do we solve this? First, we add the bases together. 14 plus 8 is 22. Then we take half of that, so the average base is 11. Now for the easy part. Multiply that by the height. 11 times 9 is 99. The area is 99 square feet. Phew, okay, let's bring it all home with a quick recap. Think of this slide as your ultimate cheat sheet. It's got every formula we covered. And really pay attention to that key tip column. Those little reminders are the secret to getting the right answer every time. This is definitely a good spot to hit pause and let it all sink in. And that's our whirlwind tour of calculating area. You seriously now have the basic tools to measure the space of almost anything around you. So I'll leave you with a challenge. Look around the room you're in right now. Find a complex object, a desk, a window, anything, and think, how could you break that down into these simple shapes and measure its area? Thanks for watching.